In this video, we'll introduce another type of task which is quite useful and popular in natural language processing. The task is word tagging. So in many NLP applications or system, it's actually going to be useful to take the raw text and actually augment it with some additional higher level data of syntactic or semantic nature. And specifically, we would like to add semantic or syntactic labels to each word in the document or in a sentence. So this problem can be tackled using some sequential classification problem, and in particular, we could use a conditional random field approach, which we've seen earlier in the course. And then we could use a neural net to model the unary potentials, where the neural net would take as input a window of words, and these words would be mapped to word representations and so on. What we'll actually describe in the subsequent videos is something that's a bit more involved, a model that's a bit more complicated than that. It's a very original model which performs really well. It was designed by Rana Colobert and Jason Weston in this paper. And before we actually look at what this model is, we'll first spend some time looking at different word tagging tasks that are popular in the NLP community. One of the simplest tasks probably for word tagging is part of speech tagging. So the idea here is that we want to take each word and identify what is the part of speech category of that word. So in other words, is it a noun, is it a verb, is it an adverb, an adjective, and so on. You could determine different types of tag sets, so different types of categories. You might want categories that distinguish between singular and plural words, or between the tense, present, or past tense of verbs, and so on. One of the perhaps most popular tag set is the Pantry Bang Pause tag set. To get a more detailed description of what it is, I encourage you to look on the web. I won't describe it further. Usually when you get a data set, you essentially have the tag set that is defined by either by referring to the Pantry Bang Pause tag set, or will be defined for this particular data set, but usually you don't really get a choice when you just take a data set from the web and to train a model. So here we have an example where, for instance, in this sentence, the little yellow dog barked at the cat. Well, we've identified that barked was a verb, that dog is a noun, yellow is an adjective, and so on. Another word tagging problem is chunking. So the idea is to segment the sentence into phrases that have a particular syntactic form a particular syntactic unit, a particular phrase. For instance, in the sentence, he reckons the current account deficit, then we could distinguish that we have he here, which is a noun phrase, reckons, which is a verb phrase. So these are simple because they're a segment that corresponds to just an individual word, but then we could chunk together the current account deficit as forming a particular meaningful syntactic unit in that sentence. And so it means that we have to somehow turn this problem of chunking or segmenting the sentence into an individual word tagging problem. And the way this is done usually is by using some sort of encoding, identifying the beginning, the middle, and the end of the segments. So one type of encoding is the IOBES encoding. Specifically, what it does is that if we have a phrase that corresponds to just a single word, then we'll just prefix S dash and then right before the type of phrase that we have. So if we have a noun phrase, then we would have S dash right in front to identify that this word constitutes a noun phrase. Like, so we have an example right here. He is just a noun phrase. The word itself is a noun phrase. And now if we have multi-word phrases, then we'll identify the beginning with B, the end word with E in the phrase, and I will use I for all the words that fall between the beginning and the end. So if you had the word phrase that contained 4 words, we'd have BVP, IVP, IVP, and EVP. And so I'm realizing now this isn't a B, this should be a P. And so in our example, the current account deficit would be, each of its word would be labeled with BNP, INP, INP, and then ENP. And for any other words that do not fall in the category trying to recognize the segments that we're trying to identify in a sentence, we will use the other label O to identify that a particular word doesn't belong to any particular phrase we're trying to, or segment we're trying to identify in the sentence. Named entity recognition is in other type of word tagging problem. This is also a case where we might have to identify segments. So we might have, for instance, to identify persons or locations which would be described by more than a single word. So in named entity recognition, we are interested in finding whether words in a sentence correspond to the identification of something that's named. So a person, a location, an organization. So I have an example here, UN officials, EQUS, probably saying that wrong, but heads for Baghdad. And in this case, we only have single word named entity. We have UN, which is an organization, so we have s-org, EQUS or EQUS, which is s-per for person, and then Baghdad, which is a location, so s-location. And then all the other words are not named entities, so they're tagged with the tag O. And finally, another task which is much more complicated than the previous ones, and is also richer and corresponds to higher level information about words, is semantic role labeling. So now the idea is that for the words in a sentence, we want to identify what roles they're playing in the semantic meaning of the sentence, and with respect to each verb that is contained in the sentence. So it means that if a sentence contains, say, 2 words, then we'll have 2 types of segmentations, one for each verb, and the segmentation will identify the roles played with respect to each verb, the roles that these other words are playing. So let's look at it. An example where there's a single verb, you wouldn't accept anything of value. Well, first we'd identify the verb with the tag V, and then we'd identify the sentence or the phrase in the sentence that corresponds to the actor of the verb. So for accept, it would be the acceptor, and one way of labeling that is with the label A0. So in this case, it's he who is accepting. So we have a single word phrase corresponding to the type A0. And then there's the object of the verb. So in this case, for accept, it's the thing that is accepted. We'll label that as A1. And in this case, the thing that is accepted is anything of value. And now it's a phrase with 3 words. We have BA1, IA1, and EA1. And then there are other tags. It could be it's accepted from what, attributes of the accept action. There can be verbs that influence the mode or that correspond to negation information. Again, I won't go into detail of how exactly what are the different types of roles that words can play with respect to a verb, but I'll let you look at the literature on semantic role labeling to learn more about that. But again, usually if we take a data set from the web, the words are, of course, already labeled for you. And so you can just look at the categories that are in the training set to know which categories you should be identifying. And whenever the data sets are distributed with word tagging information, the raw data usually looks like this. It's a text file, and essentially each line in the file corresponds to one word and all of its tags. So in this example, we have, and the different tags are arranged into different columns. So for instance, this column would be the pause tag, this would be chunking tags, these would be named entity tags. So for instance, we only have one named entity, Jupiter, and it was identified as an organization. And then I'm not sure exactly if that's the correct label, but that's what is in this data. Then what do we have? We have here the roles played by the other words for this verb here, faces, and then the roles played by the same words, but with respect now to the verb explore. Okay, so we see now that we have tags for each verb in the sentence. And so now what we'd like to have is a learning algorithm, so for instance, a neural network learning algorithm that would take all of this data and be able to reproduce it and produce these tags for new sentences. And so that's what we'll look at the in the next videos.